Welcome to this screencast. We're doing the insertion sort of our unsorted list. The insertion sort, we're going to follow this algorithm that you've got at the bottom there, and then we are splitting our lists to get started. The first element of our unsorted list will be our sorted list, and the rest is the unsorted list. So you will see that this sorted list in green is going to grow, while the red unsorted will shrink, and the stopping condition for this algorithm is when that unsorted list will be empty. Okay, we start by taking the first two elements of our list, that's 2 and 5, and we compare them. 5 is not smaller than 2, so we're in the else, and there is no next element, so we insert it last, which means in fact our sorted list is now made of 2 elements. And we repeat the same process. We take 2 and 16, and 16 is bigger than 2, we're into the else. We compare with the next element. 16 is bigger than 5, so we are back to insert it last, which we do by growing our sorted list in green. But now we are comparing 1 with 2. So 1 is smaller than 2, so 1 is going to go over here. Now, at some point, I'm going to need to redraw my list, but I've got 1 there. And then I'll compare 1 with 8. 8 is bigger than 1, so I'm in the else, compare with next element. So 8 and 2, 8 and 5, 8 and 16. 8 is smaller than 16, so I need to swap those 2 there. Well, I need to insert it, bring it before. And in order to make it all fit on my board, I'm going to have 8 inserted before 16, and my sorted list has grown 1 more, while the unsorted one is shrinking even further. I repeat the process with 15 and 1, so 15 is bigger than 1, bigger than 1, bigger than 2, bigger than 5, bigger than 8, but it's smaller than 15, so it's exactly the same thing. I need to insert 15 over here, which the result will be this, 15, 16, and the sorted list has grown. I'm almost at the end there, but the algorithm would not know that. The algorithm cannot see what we're seeing there with the colors. The first element of the unsorted list is 22, which is bigger than 1, 2, 5, 8, 15, 16, so it goes last. And in doing so, my unsorted list is now empty, which is the stopping condition for this algorithm. So we stop there with our sort finished. Thank you for listening to this screencast, and I look forward to you applying this in the lessons.